Section 2.1, Graphs of Equations. We'll begin looking at graphs of equations by looking at the Cartesian coordinate system. We'll have a horizontal axis in the coordinate system, which will represent the x values, the domain. To the right, x will be positive. To the left, x will be negative. The horizontal axis usually represents the y values, the range. Up will be positive, down will be negative. Where the horizontal and the vertical axes cross is the point 0, 0, the origin. So we'll plot our points. The point 6, 4, ordered pairs always represent first the x value and then the y value. The x value tells you how far right or left to go. The y value tells you how far up or down to go. So the point 6, 4, we want to start at the origin, go right 6, up 4. Point A is approximately there. It's kind of hard to get the points exact. Point B, 4, 6, we want to go right 4, up 6. That puts us here at point B. We begin at the origin each time. Point C, negative 3, 5. Negative 3 tells you go left 3, 5 tells you go up 5. Negative 3, 5. Point C. Point D, 5, negative 3. So we go right 5, down 3. Point D. Point E tells us to go to negative 4, negative 3. Start at the origin, go left 4, down 3. And that puts us here at point E. Point F, 4, negative 2. Start at the origin, go right 4, down 2. And that is point F. Point G, 0, 3. 0 in the x value means don't go right, don't go left. But 3 is y, so go up 3. That gives us point G. Point H, negative 4, 0. First, start at the origin, go left 4, do not go up, do not go down. This is our point, point H. So in the Cartesian coordinate system, the abscissa is another word for the x value. The ordinate is another word for the y value. The x and the y axes divide the Cartesian coordinate system into 4 quadrants. The first quadrant is where x and y are both positive, to the right and up. The second quadrant, x is negative, y is positive. The third quadrant, both x and y are negative. And in the fourth quadrant, x is positive, y is negative. Looking at graphs of linear equations, we'll first begin by just plotting points. How many points do you need to plot to determine a line? You need 2, but we always use 3 to give ourselves a check. So we have an equation here, y is negative 2x plus 3. That determines the relationship between x and y. We need to choose an x value. Choose anything you want. Could be 0. That's easy. So what is y when x is 0? Look at the equation. We have y equals negative 2 times x, but x is 0. So y equals negative 2 times 0 plus 3. 0 plus 3, 3. Let's let x be 1. We're just choosing arbitrary values. If x is 1, then y is negative 2 times 1 plus 3. Negative 2 plus 3, 1. We need a third value. If x is 2, what is y? Y is negative 2 times 2 plus 3. Negative 4 plus 3, negative 1. That gives us our 3 points. Let's plot them. 0, 3, 1, 1, 2, negative 1. Now those points line up in a straight line. That's good. If they hadn't, then we would know we had done something wrong. I'm going to do my best to draw a straight line through those points, and that represents the graph of our line. It's a good thing we recognize that this is a line. Anything that can be put in the form y equals mx plus b is a line. It's a straight line, so we can just graph it by plotting any 3 points and then plotting our points and drawing our straight line. So in this new example, we have y equals negative 1/2 x minus 3. I'm going to try to be careful when I choose my x values. Is it easy to put 0 into this equation? Yeah, it's easy, because y equals negative 1/2 times 0 minus 3. Negative 1/2 times 0, anything times 0 is 0. So that gives us negative 3 as our y value. I don't want to use 1, because if I put 1 in this equation in place of x, I get y equals negative 1/2 times 1 minus 3. That's negative 3.5. I don't like that. How about 2? Does it work? It does a little better, because negative 1/2 times 2 is negative 1 minus 3 is negative 4. I like 2 because it cancels my fraction. I don't like 3. I like 4. I want to multiply at negative 1/2 times something that will cancel my fractions. Y equals negative 1/2 times 4 minus 3. That's negative 2 minus 3, negative 5. So I'm carefully choosing x values that will give me integer answers, which will be easier to graph. 0, negative 3. 2, negative 4. 4, negative 5. Our 3 points line up. That's good. That means we probably have drawn or calculated our values correctly. So we try to draw a straight line through those 3 points, and that gives us our graph of our line. We'll be drawn in this class, but for now, we're just graphing by using 3 points. What if it's a nonlinear equation? What if it cannot be written in the form y equals mx plus b? For instance, y equals 2 over x. That's a bit of a problem. If you've never seen that before, how might you approach graphing it? We have a t-chart here, so why not try some values? Let's let x be 0. Whoops. X can't be 0. It's undefined. X cannot be 0. That's good to know. X cannot be 0. Can x be 1? Sure. If x is 1, y is 2. Can x be 2? Yeah. Y is 1. Can x be 3? I get 2/3. I don't like that. Well, what about 4? It gives me a half. That's a little better. Let's plot these points and see if we can figure out what's going on. So 1, 2, 2, 1, 4, 1/2. Boy, it looks like it's getting smaller. Think about it. If you put 10 in there, you'd get 2/10 or 0.2. It's getting smaller and smaller as x becomes larger. Something interesting is happening at 0 because it's curving down, so we know it's interesting, but we know that x can't be 0, so let's try 1/2. What's 2 divided by 1/2? 4. So it's getting closer and closer to the y-axis. Well, that's good, but we need more information. We need more points. What about negative 1? You get negative 2. Negative 2, negative 1. Let's look at that. Negative 1, negative 2, negative 2, negative 1. What about negative 4? You get negative 1 half. Negative 1 half. See what's happening here? There's a kind of symmetry to this. Oh, that was terrible. Let's try that a little better. There's a kind of symmetry to this. Well, that's not great either, but we'll go with it. I think you can tell that whatever it's doing in the first quadrant, it's doing a similar thing over here in the third quadrant. So that's an interesting graph. Maybe we can do more like that. What about this graph? Absolute value. So if x is 0, take 4 minus the absolute value of 0, you get 4. If x is 1, you get 4 minus 1, 3. 2, 2, 3, 3. Let's plot those points. 0, 4, 1, 3, 2, 2, 3, 3. Well, that's interesting, but you know it's absolute value, so I really want to put some negative numbers in it. What happens when you say 4 minus the absolute value of 1? That's 4 minus 1. That's 3. How about negative 2? 4 minus 2, that's 2. Negative 3. 4 minus 3, that's 1. What does this graph look like? It's not one straight line. It's two straight lines. It's kind of an inverted V shape. And we just have to keep graphing points until we think that we have a good idea of what the graph looks like. That's all for section 2.1. Check the next tape for the next section.